Welcome to the Sprint 3 demo for the Taco prototype project. This is Aaron Collier. I am a developer and tech lead on the project. We have Christina Harlow as data ops, Justin Coyne as developer, Aaron Fahey as DevOps, Vivian Wong as our direct liaison, and Hannah Frost, as I blank on last name, Hannah Frost as our product owner. Today we're going to walk through a quick demo of the features that are now available and deployed to AWS, and a show of the application profile as developed by Christina. And take it away, Aaron.
Okay, so leading off from a demo that Justin did a couple of weeks ago now, a few weeks ago now, we're going to show very similar actions that we've done now on our deployed AWS environment. So first we're going to hit our deployed environment, which is tacodev.sool.stanford.edu, and create and show how we're going to create a record in DynamoDB. So we're hitting the AWS endpoint now. Spits back us an identifier, which we are going to query on now. Sorry for my white weirdo highlighting. I'm gonna pretty print that. So we were able to just request through the Taco API to Dynamo, and to prove that we've actually done it in AWS, I'm going to, ignore this one for now. I'm going to show that we were able to just enter that record in. Now we want to update it, which is going to update this little label here. So we're going to make a patch request with a different JSON payload. Using the same UUID. Send that off to Dynamo via Taco. And if I refresh, you can see that label got updated, which is the only change. And we can ask for that JSON payload back through Taco on the via curl as well, and see that the label had been updated to updated. Next, we're going to upload the Readme file for Taco using our file endpoint. Get a UUID back, and we can see, well, first of all, we can see that we've made a separate record in Dynamo for that file object, as well as see the file in S3. I think that's all we had, so back to Aaron.
Now we're going to hand it over to Christina to show the metadata application profile that is being developed for Taco.
So I'm just sharing, hopefully, the correct Google Chrome screen. Yes, I think this is what I want to show. Okay, so I'm going to walk through the developments that have been going on for our data models and metadata application profiles for Taco. This is eventually so we can move beyond having the simple resource pattern that you just saw demoed to having something that actually can handle data migrated from our existing Fedora 3 instance, as well as fit all of our data modeling requirements otherwise. In starting this out, I just want to compare it with our Swagger API specification. Shows at the bottom, this is what's really driving Taco's API interfaces. But at the bottom, we have some sort of dummy resource objects model just in order to allow the code-based development to be started. So these are our holders for where we are trying to integrate our updated models, which are being developed concurrently with the development efforts in this project. Our overarching data model is derived or builds off of the Portland Common Data Model, so that's a point of community overlap with this effort. We have primarily managed by Taco, and SDR3 will be the items in blue, so collections, objects, an optional secondary or to the nth degree part object abstraction layer, file groupings or file sets, and then actual files themselves. We also have the support for adding annotations to any of those levels, as well as particular object types, which we'll see a little bit more about in a second. This model has been built out in a set of application profiles. These are all documented in the wiki of our Taco GitHub repo, broken out according to each high-level class of resource we just discussed. Objects are digital repository objects. This maps to the abstraction for works or maps to PCDM objects. We see that we've set some expectations that they should probably contain file sets, but that's not required. They could contain other digital repository objects in order to build out complex resources or complex objects as we handle them. They can have ordered members, but they should not contain collections or files. This is really to scope expectations and management of the objects or works within our resource, within Taco. I will jump past some of the abstraction scopes and content types because these will become more important as our system continues to develop outwards, and jump directly to two things I want to show. One of which is that we have currently our object resource, our object metadata application profile broken out to more fuller extent in these open to the world tables. You can see that we're intentionally leaving descriptive out as a micro schema at this point, as we work with our metadata department partners to figure out what they would like to have here for descriptive. Everything else comes either directly from requirements from people who work with Taco at this low level, or what the system itself needs to have in order to process the resources based off the requirements that we have. You'll see that we have tabs in this application profile for our other resource types, collections, which can contain other collections or objects, but should not contain files directly. Maps again to PCDM collection pretty cleanly. For this, we also have more specific information in our application profile that I won't go through currently, but it is there. File sets. This maps to the HydroWorks file sets. We are looking to use those again for administrative management of groupings of files. This also has more information on it in our evolving application profile table. And then files themselves. And a special note on files, as shown by Aaron's demo just a second ago, files are metadata records in order to manage those actual binaries. So every binary that we receive will have a file metadata resource in order to contain technical metadata, structural expectations, version information, anything that we need in order to actually manage the binary. So that's always going to be attached to a single binary. And this again maps to PCDM file. We are looking to use usage types and format types from the PCDM extensions work. Again, another point of community overlap in order to describe what our files are serving, what purposes they're serving, or how they should be used. And this also has a profile in our evolving application profile table. The other thing I wanted to show is this table is great for human readable specifications, particularly as we dive into requirement expectations, if things are repeatable or not, if they are coming from users or if they are system generated, what kind of values we should expect. This is a helpful evolution of our application profile. In tandem with this, we are also trying to write machine actionable application profiles using the JSON schema draft 6 version. These are in our maps currently. And you can see here, for example, with our digital repository object, this again is our abstraction for our work. We have defined in JSON schema information that allows Taco codebase to do a subset of validation on objects passed in that are meant to be digital repository objects. This doesn't just help with validation, but also helps us generate the structs or internal data structures that we need for our codebase to work with this while sharing the semantic expectations with our actual data models and application profiles generated elsewhere. So this is a particular step forward in trying to make sure that our data model and data understandings are coordinated and coming from the same place instead of having a spreadsheet in one place and code classes elsewhere. Finally, I wanted to show quickly, just to follow up on the profiles that we are generating, both machine actionable and human readable. We have started to pull out all of our Fedora data. We're currently using Fedora 3 and have a great number of fields that we are going to have to map. We've started taking that and actually mapping real Fedora data to example objects following our evolving data model and application profile. And we're hoping to start using these as the testing or fixture data for the Taco code base, as our next steps are to review Taco and figure out how to integrate these models into our code base so that we can move beyond the simple resource structures we have defined in Swagger currently. But all of this is taken from real Fedora data, and that should be a good example of where our modeling work is going so far. So that's all I have for the application profiles and models. Aaron, I'll hand it off to you, or if there's anything else for the group to share.
Thank you very much, Christina. I think that is it for this demo. And thank you for watching our Sprint 3 demo for the Taco prototype.